Hello guys, welcome to the channel, and today I have an interesting integral to say the least. So let's just dive straight into it. Cool, so here's the integral, and you are looking at that correctly. It is an infinitely nested radical in x, and that just basically means that we have square root of x times square root of x times square root of x, and it goes on infinitely. And I prepared a nice little hint, and the hint I prepared is that a GCSE trick can unpick this problem. So the message I kind of want to give is that whilst this does look like something very funky and something you may have never seen before, you do have the skills needed to take on this integral. So let's just dive straight into it. Cool. So the first thing I think to recognize with this integral is, of course, it's not a standard function that we would integrate with. So we kind of need to mess around and see what we can do. So a good starting point is just let y equal this infinite nested radical. And then I thought a nice idea would be to square both sides. So then on the left-hand side, y squared is just going to be y squared. And then we have this infinite nested radical squared. And this outside square root is going to cancel with the squared, so that we get y squared is equal to x square root x times square root x. And then this is quite nice because we know that y is equal to the infinite nested radical, and we have y squared here. So what we can do is we can divide this equation here with this one. So on the left-hand side, y divided by y is just going to be y. And on the right-hand side, x root x times root x divided by root x is just going to be x. And so then we get y is equal to x. I'm going to put a purple box around it because that's part of our solution. And in terms of the GCSE trick I'm referring to, it's kind of similar to writing recurring decimals as fractions. So I'm sure that's something you remember. Writing like 0.33323 as a fraction, whatever. And so that kind of skill you can kind of be translated across here. Cool. So I just thought of other ways to express it because this may not look intuitive at first. And here I have a graph. So the blue line is just y is equal to root x, and the green line is y is equal to root x times root x times root x. And then the red line is the same thing with 8 of these nested radicals. And we can clearly see that as we add more nested radicals, the line is moving upwards and upwards towards straight. So it's not quite there yet, but it's almost there. And then I thought of another way of doing this as well, which is also a very clean way of doing it, which is if we look at the pattern of having, if we have one nested radical, just x, then that's equal to x to the half. If you have 2, is x to the 3 over 4, and 3 of them is x to the 7 over 8. We can then kind of make like a sequence where n is a number of nested square roots. We can say that the power of x will just be x to the 1 minus 1 over 2 to the n. And then, since it's an infinite sequence, we can just write this as a limit, like so, with n tending towards infinity. And just by solving the limit, 1 over infinity is always going to be 0, and we get to x. So that's another nice way of doing it as well. And it all gets to the same conclusion. And so here we go. So now it actually ends up simplifying a lot, just like so. And now we just need to integrate x dx. And that's just integrating with polynomials. And you get x squared over 2. And then it's nice to remember that plus c. And there you go. That's our answer. So let's chuck a green box around it. And there you go. If you want to solve more integrals, then feel free to look in the playlist or in the description. And otherwise, I hope you enjoy this problem. And I look forward to seeing you guys next time.